something has entered our solar system, and it's not leaving quietly. An object from deep interstellar space designated 3I Atlas was originally expected to simply glide past Mars in a harmless flyby. But in the last few days, everything has changed. A joint emergency briefing by NASA and Harvard has revealed a grim possibility. This fast-moving interstellar body may now be on a direct collision course with Mars.
I don't believe it.
Let that sink in. We are no longer talking about a distant light in the sky. This is a volatile, hyperactive comet from another star system, now barreling toward a planet that holds the future dreams of humanity: colonization, exploration, and survival. If 3I Atlas does impact, the result won't just be a new crater. It could be a planetary catastrophe. The first red flags emerged when subtle deviations in the object's trajectory were detected by NASA's deep space radar and Harvard's astrophysics labs. These weren't random noise. The orbital path of 3I Atlas began warping, curving closer and closer toward the red planet. What began as millimeters of drift evolved into kilometers of realignment, until Mars found itself sitting in the bullseye. But this isn't just about geometry. 3I Atlas is no ordinary rock. It's active, erupting with high-speed jets of gas and dust as it nears the sun, each outburst acting like a microthruster. These violent spurts constantly alter its motion, making any prediction a moving target. And it's accelerating. Right now, scientists estimate that impact could occur by late October, just weeks from today. And there's no rescue mission, no deflection plan. The object is too fast, too far, and too unpredictable. It's not just the speed, over 50 kilometers per second, but the chaotic nature of the comet's surface, which is rapidly fragmenting under solar stress. Think of it like this. Imagine trying to catch a grenade mid-air. Only the grenade is made of ice, hissing gas, and alien minerals from a distant solar system. If it hits, the consequences are staggering. The energy released could rival the detonation of every nuclear weapon on Earth combined. Mars, with its thin atmosphere and fragile surface infrastructure, is utterly exposed. Satellites, rovers, research stations, all are in jeopardy. And even more chilling, the dust cloud from the impact could wrap Mars in a shroud of darkness, triggering an artificial winter across its hemispheres. Terraforming efforts would be erased. Robotic operations may shut down, and any hopes of manned missions could be set back by decades. But here's the deeper question no one is ready to ask. What does it mean when an object from beyond our solar system disrupts our plans to colonize another world? Is this just a cosmic accident, or a brutal reminder that the universe does not bend to our ambitions? That even with all our satellites, simulations, and predictive models, we are still flying blind through a universe of chaos? This is no longer just an astronomical event. It's a test of our ability to understand, respond to, and survive cosmic threats. And with each hour that passes, the margin for error shrinks. Welcome to the countdown. The moment the trajectory shift became undeniable, panic spread quietly behind closed doors. NASA's Jet Propulsion Laboratory and Harvard's Center for Astrophysics initiated around-the-clock tracking. Observatories worldwide, Chile's Very Large Telescope, Hawaii's Keck Observatory, ESA's ExoMars redirected their focus. This wasn't a drill. It was an unfolding planetary threat. And yet, despite all the eyes on the sky, a chilling truth emerged. There was nothing anyone could do. The window to alter 3I Atlas's course had already closed. Why? The answer lies in brutal physics. At over 50 kilometers per second, the interstellar object is moving too fast for Earth-based intervention. Kinetic impactors, nuclear deflection, none of these options can reach it in time. Mars itself is over 200 million kilometers away, and even if we launched today, we'd arrive long after the fact. The only tools left are observation and modeling. No missiles, no miracles, and modeling is not reassuring. 3I Atlas is a wildly volatile comet, not a solid rock, but a body of dust, gas, and ice under constant transformation. As it approaches the sun, its outgassing increases, releasing plumes of vaporized material that push and pull it unpredictably. NASA's data scientists call this the microthruster effect, random jets of gas that cumulatively shove the object off its previous path. Each outburst alters its momentum. Each change increases uncertainty. The comet is in essence rewriting its own trajectory in real time. Harvard's team raised another alarm: fragmentation. If 3I Atlas breaks apart before impact under solar stress or from internal fractures, it could unleash multiple high-speed shards. Rather than a single concentrated strike, Mars could suffer a cluster bombardment with fragments striking across hundreds or thousands of kilometers. That possibility makes evacuation planning, impact prediction, and infrastructure protection virtually impossible. And then there's what's on board. Spectral analysis of the comet's coma has detected unfamiliar organic compounds, metallic inclusions, and gas signatures never seen in local solar system comets. This is more than a rock. It's a chemical time capsule from another star system, possibly containing building blocks of life forged under alien conditions. But if it hits Mars, that ancient chemistry may never be studied. It will be annihilated in the blink of an eye. Every passing day adds another layer of uncertainty. Mars' orbiters, Perseverance, China's Tianwen-1 ESA's Trace, Gas Orbiter are all preparing to record the moment. Instruments are being reprogrammed, solar panels are retracted, power is rerouted to data collection systems. Engineers know that the shockwave may destroy these machines, but if they can transmit just a few final frames before the signal cuts, the world will have a front-row seat to one of the most consequential impacts in human history. In the absence of intervention, our last line of defense is information. But the data now paints one brutal message: the impact is no longer a matter of if, but where and how bad. As the confidence interval for impact climbed past 99%, a profound shift rippled through the global scientific community, from analytical detachment to a haunting sense of impending loss. Mars has always been more than rock and dust. It's been a mirror for humanity's future terraforming dreams, robotic exploration, whispers of ancient water, and possibly ancient life. But now that future stands on the brink of obliteration, thanks to a visitor born in the void between stars. The collision of 3I Atlas. This interstellar object we barely understand could erase decades of progress in one violent instant. Nowhere is the emotional weight heavier than among planetary scientists. These aren't just researchers, they're pioneers who've spent careers mapping Martian terrain, designing robotic explorers, simulating potential colonies. Places like Olympus, Mons Valles, Marineris, and the polar caps aren't just names to them. They're landmarks, almost sacred. And now, simulations show those very regions might become impact zones, depending on where the comet strikes or where its fragments land if it breaks apart before arrival. Publicly, agencies like NASA, ESA, and CNSA maintain calm. But behind the scenes, chaos is brewing. Private space firms SpaceX, Blue Origin are scrambling to launch last-minute observational drones. India's ISRO has pledged deep space tracking assets. Even traditionally secretive agencies like Roscosmos and CNSA have agreed to share real-time telemetry. For a moment, geopolitical rivalry has been eclipsed by shared existential vulnerability. The universe doesn't care about borders, and neither does this comet. Meanwhile, engineers face agonizing decisions. Do they risk keeping Mars-based systems active longer to capture final data, or shut them down early to protect hardware AI systems? On board, the rovers are being reprogrammed to prioritize high-value data packets, knowing that transmission may cease mid-transfer. If the signal drops, decades of work could vanish into Martian silence. In mission control centers across continents, eyes are fixed on countdown clocks, and every alert is followed by a wave of anxiety. But it's not just hardware at risk. Harvard's astrobiologists are deeply troubled by the potential biosignature loss. Beneath Mars' frozen surface may lie dormant microbial ecosystems, trapped in aquifers shielded in rock. A massive impact could sterilize those zones, completely vaporizing or contaminating what could have been the first proof of life beyond Earth. Worse yet, the shockwave might momentarily awaken microbial life in meltwater pockets, only to destroy it seconds later. The tragedy isn't just physical, it's epistemological. What we might lose is knowledge we've spent centuries chasing. And there's another angle no one can ignore: Earth. While Mars bears the brunt of the impact, the aftershocks could ripple through the solar system. Ejecta launched from Mars might enter heliocentric orbits. Some fragments, tiny, cold, but fast, could intersect Earth's trajectory years later, posing a threat as micrometeorite storms or atmospheric anomalies. Though the risk is low, it's not zero. Satellite networks, near Mars communication relays, and even future crewed missions to the Red Planet may find themselves navigating an orbit cluttered with high-speed debris. The philosophical implications are equally staggering. For centuries, Mars has represented hope, a second chance for civilization. To witness that dream torn apart, not by war politics or economic collapse, but by a rogue interstellar projectile, is a reminder of how fragile our ambitions truly are. And yet amid the dread, some whisper of the green flash, an optical phenomenon seen as 3I Atlas nears the Sun, emitting light refracted through its volatile coma. Some see it as an omen, others a sign of beauty and destruction. But either way, it is a final flare before the end. The closer 3I Atlas gets, the less we can predict. Will it hold together? Will it shatter into a shotgun spray of devastation? Will the impact trigger atmospheric collapse, or perhaps paradoxically brief warming and new weather cycles? No one can say with certainty, but one fact is clear: the universe has delivered a reckoning, and we have no choice but to watch it unfold. The final days before impact have become a global vigil. Every observatory, every sensor, every deep space antenna is now synchronized in one purpose, bearing witness. Around the world, the name 3I Atlas has entered the public imagination, not as an astronomical curiosity, but as a symbol of what we cannot control. The same object that once flickered faintly at the edge of our solar system has now become the centerpiece of humanity's most critical observation campaign. But what we're watching is not just a comet. It's a collision between hope and reality, and the outcome may redefine how we see ourselves in the cosmos. On Earth, classrooms have transformed into impromptu mission control centers. Students learn orbital mechanics in real time, watching simulations of 3I Atlas's Mars flyby spiral into near-certain impact. Philosophers and theologians debate its meaning. News anchors struggle to explain the technical data without inciting panic. But the truth is both simple and staggering. We are spectators to the largest interplanetary impact in human memory, and possibly the most scientifically significant since the formation of the solar system itself. Inside, NASA engineers have one final task: precision timing. Instruments across Mars are now calibrated to the millisecond. They must catch the first flash of collision, the eruption of the shockwave, the color and chemistry of the ejecta. Even if only for minutes before being destroyed, the rovers and orbiters must tell us what happened. A singular data packet could rewrite what we know about interstellar comets, Martian geology, and planetary vulnerability. Algorithms have been restructured to prioritize thermal plumes, shock front velocities, and dust grain compositions. We may lose the machines, but not before they speak. And if the impact unfolds as projected, the devastation will be planetary in scale. A shallow angle strike across Mars' southern hemisphere, traveling eastward at over 58 kilometers per second, would excavate a basin larger than any seen in modern history. Shock waves would travel through Mars's crust like glass, under stress cracking fault lines, collapsing cliffs, vaporizing surface layers. Dust and rock would be flung high into orbit, possibly creating a temporary ring system around the red planet. For weeks, the sky above Mars could glow with scattered light from its own pulverized terrain. But amid the destruction, lies a paradoxical promised discovery. If even one probe survives underground or shielded inside a crater wall, it might detect ancient layers never touched by drills or landers. Compressed ice, buried minerals, or even fossilized organics could be revealed in the blast. Some even suggest the shock may create a brief meltwater environment ideal for catalyzing new chemical reactions, an unintentional high-speed laboratory seeded by interstellar origins. In a cruel twist, the destruction could answer questions Mars has hidden for billions of years. Yet this would come at a terrible cost. Future missions would be delayed by decades. Communications infrastructure around Mars might be obliterated. Even Earth's deep space relays could be knocked out by stray ejecta. And the psychological fallout, immeasurable. Humanity's boldest aspirations, terraforming colonization, even the dream of turning Mars into our second home, would be reduced to debris. Still, we cannot look away. There is something deeply human about watching the sky, knowing we cannot stop what comes, but choosing to understand it anyway. 3. Atlas reminds us that the universe is not ours to control, it is ours to observe, interpret, and respect. We may never know why this object entered our system, whether it was cast out from a distant supernova or dislodged by a forgotten gravitational dance in a faraway galaxy. But we do know this: its path has now intersected ours, and the story it writes on the surface of Mars will echo for generations. In the hours to come, the final data will arrive. Then silence, dust, and a new Martian landscape forever changed. What began as a NASA data delay, a subtle deviation in course, has become a moment that might define 21st century space exploration. The green flash has passed. The countdown is nearly over, and so we ask if this is what one interstellar visitor can do to a neighboring planet. What else is lurking in the deep black still unseen?